classification. So one of the biggest problems or the main problems in machine learning and language processing or data processing, data mining is classification. इसका कुछ piece आप लोग पहले देख चुके हैं. For example, you had a continuous piece of text and you wanted to put full stops. कि इधर full stop आना चाहिए, इधर full stop आना चाहिए, and so forth, इधर full stop आना चाहिए. And you're basically trying to classify every point as either full stop आना चाहिए या नहीं आना चाहिए. Should there be a full stop or should there not be a full stop? So you're trying to classify at this location as a binary classification, yes or no. And how do you do this? You basically are looking at, or were looking at, the features of this location. कि इसके पीछे क्या है, इसके आगे क्या है, and so forth. These are called features. आगे कोई जो word start हो रहा है, is it capitalized or not? This is one feature. And there are many such features जो आपने rules में embed किए थे. But generally, classifiers, they work in this way कि you have features and you look at those features in some n-dimensional space. And let's look at two-dimensional space. And let's say in this case, you have voice data. So let's say you have this person who's speaking and you're getting this voice sample जो कि आपके इधर relevant है. And let's say it's not one person. This is a conversation between two people. And you do not know कि भाई when the first person is speaking, which is red, and when the second person is speaking, which I mark as blue. ठीक हो गया? So let's say you're trying to classify the sound sample. कि कौन सा piece speaker 1 बोल रहा है और कौन सा piece speaker 2 बोल रहा है. So let's say speaker 1 is red and speaker 2 is blue. So what would you do? What you do is you look at some features of this sound. तो आप पहले तो ये करेंगे कि you break this down into smaller chunks. Smaller contiguous chunks में आपने break कर लिया इसको हर सारे sound sample को. And you are trying to mark each sample as being of speaker 1 or speaker 2. ठीक है? दूसरा काम आपने ये किया कि you look at the features of each of these samples. And let's say we have multiple features जो हम निकाल सकते हैं from sound samples. Let's say कि हम दो features लेते हैं, frequency and pitch. And we map all these samples on this two-dimensional graph or two-dimensional space as being belonging to speaker 1. And those that belong to speaker 2. बल्कि इनको कोई और सिंबल यूज करता हूं माइनस. सही है? Now we want to build a classifier to distinguish the two samples. तो obviously हमें ये नजर आ रहा है यहाँ पे कि जो जहाँ frequency ज़्यादा होती है तो it's basically speaker 1. तो speaker 1 basically is talking with a higher frequency जो कि हमें visually नजर आ रहा है यहाँ पे. लेकिन actually what the classifier would do, it would look at these features or in reality multiple more features and will do something like this. So it will say okay, I am trying to identify speaker number 2. So all of these samples that I have circled belong to speaker 2, and the rest of the samples would belong to speaker 1. So this is called binary classification. You take one of the two classes and say, okay, I'll identify this class and the rest of the samples would belong to the other class. ठीक हो गया? So now, how do you evaluate that this classifier, which has been marked by this circle, how good is this classifier? So basically, it's classifying this point correctly, this point correctly, this points, all these points correctly, and these points incorrectly. Similarly, it's classifying these points incorrectly as belonging to speaker 2, whereas they belong to speaker 1. Okay? And it classifies these points correctly as belonging to speaker 1. Okay? So what do we say? So these samples inside which have been correctly identified as belonging to speaker 2 are called true positives, TP. Okay? And these samples which have been classified as speaker 2 but they belong to speaker 1 are called false positives. Okay? True positives and false positives. Similarly, the samples which lie outside the domain of this classifier, यानी classifier उनको negative या outside its classification zone classify कर रहा है, तो and it's not selecting these are false negatives, these are false negatives. It says they do not belong to speaker 2 whereas they do, and these are true negatives. So essentially, we have a true and a false. True going with classifier ने सही काम किया, और false going with classifier ने गलत selection कहाँ पे की हुई है. ठीक है? So we use these concepts of true positives, false positives, and true negatives and false negatives to describe the accuracy of a classifier. Accuracy तो वैसे is a simpler metric. Accuracy, what would accuracy be? Accuracy तो ये होगी कि जितने इसको select करने चाहिए थे उसमें से कितने select कर लिए. Let's suppose कि इसको out of 100 samples, out of a total of 100 samples, it classifies 60 of them correctly. Yani these are true negatives and true positives. So that's accuracy. तो उसका formula कुछ ऐसे बनेगा. These are true positives plus true negatives divided by the total number of samples, which is true positives plus true negatives plus false positives plus false negative. ठीक है? तो ये तो है accuracy. But accuracy does not really measure the quality of a classifier in the sense कि बहुत सारी classes ऐसी होती हैं जिनके samples को बहुत कम होते हैं. For example, you are not recognizing this sound, या speaker 1 बहुत कम बात करता है, speaker 2 बहुत ज़्यादा बात करता है. So there will be a discrepancy in the number of samples here. Okay? So let's say कि 90% of the time speaker 2 is speaking and speaker 1 is speaking only 10% of the time. तो अगर ये आपका classifier कहता है कि all of this speech is speaker 2, so it will be 90% correct, and that's not a good evaluation of the classifier. तो इसके लिए I'll have to remove this and describe to you the notion of precision and recall. So precision basically measures what percentage of these selected samples are actually correct. So this is given by the true positives that you got divided by the true positives plus the false positives. So these are all the samples that the classifier selected. जो दरमियान में बना हुआ था, and these are the correct ones. So this is called precision. What you wanted to select, how many of those which you selected are actually the right ones. Recall captures what percentage of correct items have been selected, which is the number of true positives divided by the ones which were on the left side, which are true positives plus false negative, जिनको वो select करना भूल गया. So this is precision. And then what we do is we can combine these two to calculate what is called the F measure or the F1 measure. And it's actually an average of these two. And not really an average, but it goes towards the lower bound of the combined average, which is called the geometric mean. So average would be the arithmetic mean, but what we are trying to get is the geometric mean, and it's calculated as 2 times.
सर एक बार प्रिसीजन और रिकॉल का दोबारा बता दीजिएगा प्लीज.
अच्छा चलें इसको पहले लिख लें. F1 measure, I'll talk about precision and recall once again. So
Okay.
F1 measure basically is the geometric mean which takes precision P and recall R, multiplies it by 2 and divides it by the sum of precision and recall. Okay? So this is the geometric mean of precision and recall. मैं precision और recall को फिर से बता देता हूँ. सही है. तो one way of representing our classification results is by using confusion matrix, which is also called a contingency table. So this is talking about your classifier, okay, how many of the samples it selected were actually correct and they were not correct. ठीक है. So these are the samples which have been selected by the classifier, वो जो circle बीच में बना हुआ था, right? And these are the samples not selected, but they should have been selected. So they should have been here, and these are the correct ones. ठीक है. So as we described, okay, if the selected samples were correct, these are called true positives. See? And if the samples were not selected and they're not correct, these are true negatives. So this is what we wanted to maximize. हम इसको maximum करना चाह रहे थे कि we get everything in here. Now, on the other hand, what we also get is items which are selected but they are not correct. So in our example, we selected the sound sample as belonging to speaker 2, but it belonged to speaker 1. जो हमारे पास negative samples circle में आ गए थे. So these are false positives. Okay? Similarly, there were samples which were actually belonging to speaker 2, but they were not selected. So these are false negatives. ठीक हो गया? Now, looking at this is what we are interested in, to maximize the true positives and true negatives. And these are the bad ones. These are the bad results. So precision, when we are measuring precision, we are saying it's a true positives, all the true positives over these selected samples. Say true positives plus false positives. ठीक हो गया? So basically capturing how many of the selected samples are correct. These are all the selected samples. See, जो circle के अंदर है. And these are the ones which were correct amongst those selected. So what percentage of selected things or items are correctly identified by the classifier? That's being captured by precision. See? So basically looking at this line, this row altogether. Then recall, what it's doing, it's saying, okay, how many of the correct samples have actually been selected, which is looking at this column. So true positives over true positives plus false negatives, right? So these should have been selected, लेकिन उसमें से कितने actually select हो गए, ठीक है? So that's giving you the recall. अच्छा, now let's do an example. See, let's do an example and probably you will figure out this better with the example. So let's say we have this sample जिसके अंदर स्पीकर 1 बहुत ज़्यादा बात करता है और स्पीकर 2 काफ़ी कम बात करता है. तो we have these selected and not selected, and these are correct and these are incorrect. And this is the problem of imbalanced data. So let's say कि 8 samples ऐसे हैं जो आपके क्लासिफायर ने कहा कि these belong to speaker 2 and they are correct. See, 2 of the samples of speaker 2 were not corrected, not detected by the classifier. तो ये misdetection हो गई इसकी तरफ से. So basically all samples that belong to speaker 2 are 10. And let's suppose के speaker 1 के samples, there were 32 of these which were selected but did not actually belong to speaker 2, लेकिन ये speaker 1 के थे जो बीच में आपके classifier ने detect कर लिया. And let's say you have 968 samples which were classified as not selected, जो कि speaker 1 के थे, and our classifier says हाँ these are outside of speaker 2 samples. ठीक है? So you see that the data set is imbalanced. There are only 10 samples belonging to speaker 2 and there are 1000 samples which belong to speaker 1. So what would precision be? Precision in this case would be tackling this row. So it will be the correct samples divided by the total number of samples selected by the classifier. We're looking at this row. So that would be 8 plus 32, and this turns out to be 8 over 40, which is 1 over 5, and that's 0.2. That's the precision of this classifier that selects 8 out of the 10 correct samples, okay? But also classifies 32 of the incorrect samples as belonging to speaker 2. Now let's look at recall, and we are looking at this column now. Okay? So the recall of this would be the true positives, 8 over 8 plus 2. Okay? That's a 10. So 8 over 10, and that would be 0.8. So the recall is pretty good, but the precision is bad. Recall का मतलब है कि जो samples इसको पकड़ने चाहिए थे वो उसमें से कितने इसने पकड़ लिए, तो that's good. Precision was कि जितने sample इसने detect कर लिए उसमें से कितनी percentage इसकी correct है, so that's pretty bad. Okay? And that's why you need to combine these two into an F1 measure. So what's the F1 score? और ये बहुत ही क्लासिकल तरीका है to measure the effectiveness or evaluating a classifier. That would be 2 times PR, 2 times 0.2 multiplied by 0.8 and divided by the sum of the two, which turns out to be 1.0. या मैं लिख देता हूँ 0.2 plus 0.8. ठीक है? So what would this become? This would be 2 times 0.2. क्या बनेगा वैसे? Calculate करे कोई? That would be 0.4 and 0.32. 0.32 बनेगा according to my calculations. ठीक है? And you see कि it's not the
सर वही
mean.
बनेगा.
It's not the average of the two. It's inclining more towards the bottom side. So geometric mean इसी तरह होता है कि it goes towards the lower of the two things. See? So it inclines. It's a mean of the two. It's in between these two values. लेकिन it inclines towards the bottom side or the lower side. So it gives.
So तो exact. So ये F1 exactly क्या represent?